We're also going to learn polygon angle sums, so like how many degrees are in a quadrilateral or a pentagon or a hexagon. That's where we're going with this. Today we'll start with triangles. We're also going to classify them. All right, so there's two ways you can classify a triangle. Obviously, we know they're three-sided closed figures, okay? But you can classify them either by the number of, the lengths of the sides or the types of sides they have, or also by their angle measurements. So you'll see there's two kind of columns in this chart. So an equilateral triangle is a triangle that has all three sides congruent. So all congruent sides. Now I put in parentheses, it will also have congruent angles, but technically that's not what the word equilateral means. It means that they have the same lengths of sides. Now, markings, as we know in geometry, are super important in order for us to conclude something is equilateral. So you would not be able to just look at it. You would have to see markings. So you'd have to see like one congruent marking on all three sides to prove that it was equilateral. Anyone remember what an isosceles triangle is? Justin? Two congruent sides. Okay, it has at least two congruent sides. Technically, an equilateral is also isosceles. But isosceles is not always equilateral.
Please excuse the interruption. Andrew Hoffman, please report to the front lobby. Andrew Hoffman, if you're in the building, please report to the front lobby.
And so we would mark two of the sides are being congruent. Now, it also will have two congruent angles. Just giving you a little insight into the isosceles triangle theorem that we'll learn later. But it will also have two congruent base. These are called base angles. They're at the bottoms of the two congruent sides. But that's not technically part of the definition by sides, but I'd just like to introduce it to you because you might use that fact. And then a scalene triangle has no congruent sides. All of them are different lengths. So like 3, 7, 10. Markings-wise, they're going to have different markings on each side. So one marking here, two markings there, three markings there. You also could see numbers to indicate that they're different lengths. The other way we can classify a triangle is by its angles. So this is pronounced equiangular, and that is a triangle that has all congruent angles. Okay, again, it's also going to have all sides congruent, but equiangular is talking about the angles. So an equilateral triangle will always be equiangular, and an equiangular triangle will always be equilateral. But those are two different ways to classify. We would mark the angles in this one. So 3 congruent angle markings. Remember, those are just little curves. You could put 2 everywhere, 3 everywhere. Okay, an acute triangle will have all acute angles. All of them are less than 90 degrees. Remember, that's the definition of acute, is that it's greater than 0 but less than 90. There's no markings for acute. You could see numbers, measurements, but there's no markings to put in there. Now, a right triangle, is that going to have all right angles? No, because triangle sum tells us we can only have 180 degrees. So a right triangle is going to have exactly one, only one right angle. The marking for that, of course, is a right angle box. The other two angles would have to be acute because the other two would have to add to 90 together. Same thing with an obtuse triangle. Some students will think that all the angles are obtuse. That can't happen, otherwise it won't follow triangle sum. So it will just be that there is one obtuse angle, the other two have to be acute, that way they can add up to 180. Alright. So the triangle angle sum theorem, which we did talk about earlier, just says that the sum of the measures of the angles in a triangle will always be 180 degrees. So if you were using this theorem in a proof, okay, in the statements column, since this has angles A, B, and C, we would say the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And then the reason would be the triangle angle sum theorem, or the triangle sum theorem, we usually shorten it. Okay, so a couple easy examples below. find the measure of angle 1 using triangle sum theorem. So we know that the three angles together have to add to 180, so that would be the measure of angle 1 plus 35 plus 65 has to equal 180. So really we're just subtracting 35 and 65 from 180. Do you have to show this work? No. If you want to, you can. But we would get now the second one, we are given a notation, a marking. This is a right angle, which means that it is 90. So go ahead and use triangle sum to find the measure of angle W. The measure of angle W. What do we get? Mike? 57. Again, you don't have to show work for these if you don't want to. You can just take 90 minus 33, because you know 180 minus 90 is 90. All right, let's make them a little bit harder. So we're going to have some triangles within triangles, overlapping, etc. Now, some things you're going to want to use, of course, are triangle sum, but you also want to look for straight angles. Anytime you see a linear pair, we know that those two angles have to add to 180. So anytime you see something like this, if you know one of the angles, you can always find the other because you know they're a linear pair supplementary. Okay, that's going to be useful in a lot of these problems. So looking at this, we can see actually there's three triangles. There's triangle FGJ. Or is that an I? Can't tell. We have IGH, and then we also have FGH. So there's three triangles that are actually pictured. So you can use triangle sum 3 times, really. So I would use it first with this triangle. Okay? So we can see that x plus 65 plus 39 would have to equal 180 in that triangle. We'll add and subtract those numbers, or just subtract them. And what do we get for x? Right? 76 degrees. Now once you get the measure of one of those angles, you probably want to go write it in the picture because it can help you to find some of the others. Okay. Now to find the measure of angle y, if we notice, x and y together form a linear pair. Okay, there's a straight line there. So we know that x is 76. How big would y have to be? Huh? 104 degrees. We know together that these have to be 180 as well. Again, try and squeeze that back in the picture. Now to find z, there's 2 ways you can do it. You can use this obtuse triangle that's on the side, which most students would like. We have one of the angles is 104, one's 21. Use triangle sum to find the last one. You also could use the large triangle, knowing that this angle is 65. This whole angle up here, we can find by adding 39 and 21, and then subtract z. But I would probably use the scale, this obtuse triangle we see here. So we'd have 21 plus 104 plus z equals 180. So what do we get for the measure of z? Ethan?
Z equals 65.
Close. Close, close, close. 55. Should be 55. I want you guys to try the next one on your own. Now, you will notice that this one has some right triangles in the picture. So this up here, angle C, is a right angle. This angle is a right angle. What other angle can we conclude is a right angle if we know those are right angles? Jeremiah?
The opposite ones from the sort.
Yes. You can add in a right angle box right here because these form a linear pair, and if one of them is 90, 180 minus 90 tells you the other one has to be 90. So that might help you a little bit in finding the values of A, B, and C. How about A? Aaron? Very good. And B? Luke?
20 degrees.
Also 20, very good. All right, the next one asks us just to classify. You will see some of these on your homework. You have to classify it using both classifications, so by angles and by sides. So based on its sides, the markings we see, what would we call this triangle? Would we call it equilateral, isosceles, or scalene? Justin? Isosceles. How about based on its angles? And you do have to use your eye to judge the angles. Do you see all acute angles? Do you see one right angle? Do you see one obtuse angle? What do we think? We classify this by angles. Abby, what do you think? They are all acute. Very good. Now, technically, you could call it an isosceles acute or an acute isosceles, but most of the time, they'll put the word acute first. I don't really care, though. So it would be an acute isosceles triangle. All right, now a couple more using both triangle sum. We're also going to throw in some of our parallel lines. Okay, those aren't going away. We're going to use some of those in some complex pictures. Now there is a mistake on your paper. I should have marked that these two angles were congruent. So if you can go ahead and add the red markings onto your paper before we start. So they ask us to find the value of x. Normally we would think, okay, well, I could use triangle sum, right? And 20, and then this, and then, uh-oh, I don't know what this is. Okay. Now we do notice these two angles are marked as congruent. What type of angles are these? Notice we have parallel lines. How can we classify those angles? Okay, alternate interior, same side interior, alternate exterior. Right? These are corresponding angles. CA, corresponding angles. Because the lines are marked with the parallel markings, we can use the corresponding angles postulate, which tells us since the lines are parallel, the angles have to be congruent. So if this is x degrees, this also has to be x degrees. If they're congruent, they're equal in measure and definition of congruent angles. Like if one were 50, we could say the other were 50. We're just going to leave the variable. Now by markings, this was marked as congruent to this. So if this is x degrees, this is also x degrees, and that's just by markings, not by anything parallel. Now we can use triangle sum with this triangle. Okay. So triangle sum tells me if I add all three angles, they have to add up to 180 degrees. What do I get when I add x and x? No? 2x. Make sure you don't put x squared. And then go out and solve that out and see what we get for x, if you haven't already. Answer? Aaron? 80. Subtracting, we get 2 equals 160, and divide. Now double check plugging those back in. 80 plus 80 plus 20 does get me 180. Okay. Last one then, similar in the fact that it has algebra. We are given 3 expressions to represent angles. Just like you would add numbers and set them equal to 180, we're going to add all 3 of these angles and set them equal to 180 degrees, which is triangle sum theorem. So we'll have 5x plus 40 plus 10x plus 3x minus 4, and that will equal 180. You do have to add your like terms first. which if this were a proof, remember our reason would be simplify anytime we combine like terms. So we have 5x plus 10x, which is 15, plus 3, which is 18x. We have a positive 40. Be careful, this is a minus 4. So 40 minus 4 would get me 36. Biggest mistake is that students will put 44. So just pay attention to the symbol. And then you know how to solve for x from here, right? Subtract 36 and divide by 18. What should we get for the value of x? Justin? 8. And then you could take and plug those back in. It didn't ask you to, but you could always verify that the angle measurements you get when you plug in 8, that they do add back to 180. Okay. Closure. Draw and mark a triangle to fit each description. If no triangle can be drawn, write not possible and explain why. So again, you want to draw, if you can, an acute scalene triangle. Again, you want to mark it to show either sides or angles are a certain way. And if not possible, you will write not possible.